Exercise 7.1. Question number 1. How many 3-digit numbers can be formed from the digits 1, 2, 3, 4 and 5? Assuming that first part repetition of the digits is allowed, second part repetition of the digits is not allowed. So let us solve question number 1. So solution 1, and here we are having how many 3-digit numbers can be formed. So let the 3-digit number be of the form, let the 3 digits let the 3-digit number be of the form x1, x2, x3. So this is the 3-digit number form, and let us do the first part now. Case 1, repetition of the digits allowed. Repetition of digits is allowed. So how many digits are given to us? There are 5 digits: 1, 2, 3, 4 and 5. So x1 can be filled up, because what it says that repetition digits allowed. That means if we have filled x1 with 5, say suppose number 5, then we can fill x2 also with 5, x3 also with 5. That means the same number can be repeated 3 times. So x1 can be filled in how many ways? There are 5 ways. So x1 can be filled in 5 ways. X1 can be filled in 5 ways. Then x2 also can be filled, because repetition is allowed here, so it can be filled by any of the digits 1, 2, 3, 4 and 5. So x2 can be filled also in 5 ways. Can be filled in 5 ways. And what about x3? x3 also, there is no restriction that it cannot be filled up by any of the digits. So there are 5 digits, therefore x3 can be also filled up in 5 ways. So x3 can be filled in 5 ways. Therefore what we can say that number of ways in which x1, x2, x3 can be filled up. Number of ways in which the 3-digit numbers can be formed. The 3-digit number of ways in which the 3-digit number can be filled up. 3-digit number x1, x2, x3 can be filled up is equal to 5 into 5 into 5, that is 125 ways. So that means how many 3-digit numbers are there in which these 5 digits are appearing and repetition allowed? They are 125. So there are 125 ways in which we can get the number x1, x2, x3, in which the digits 1, 2, 3, 4 and 5 are there, and repetition is also allowed. Now let us go in the next part, that is when second part will do when repetition of digits is not allowed. So second part, repetition of digits is not allowed. Repetition of digits is not allowed. So here also we can do the same way. The format of the number we have taken is x1, x2, x3. We can just visit back here. The form which we have taken of the number is x1, x2, x3. So x1 can be filled up in how many ways? Repetition is not allowed in this. The number is of the form. X1, x2, x3, and digits cannot be repeated, and digits cannot be repeated. So this is the condition in second part. Therefore, what we can say that x1 can be filled up by any of the digits 1, 2, 3, 4 or 5. So x1 can be filled up in 5 different ways. x1 can be filled up in 5 different ways. Can be filled up in 5 ways. x1 can be filled up in 5 ways. Similarly, we can fill x2. Now x2 can be filled up in how many ways? Not 5 ways, because here when we are filling x1 first time, one of the digits out of 1, 2, 3, 4 and 5 have been used. So remaining will be only 4 digits. So x2 can be filled up in only 4 ways. So x2 can be filled up in 4 ways. Can be filled up in 4 ways. Same way, now filling x3. Filling the position of x3, this is our x3. So this can be filled up in how many ways? Because we have used x1 can be filled up in 5 ways. One number has been used here. In x2 also we have used one number. So for x2 there are 4 numbers, 4 digits which can be used. For x1 there are 5 digits which can be used. x2 4 digits can be used, and for x3, because one digit has been used for x1, 1 for x2, so 5 minus 2, that is 3 digits. So x3 can be filled up in 3 ways. x3 can be filled up in 3 ways. Therefore, by the fundamental principle of counting, in how many ways we can fill up the all the digits of x1, x2, x3. Therefore, number of ways in which x1, x2, x3 can be filled up, that is equal to, if we apply the fundamental principle of counting, that is, because x1, x2, x3, filling up x1, x2, x3 is a continuous process, so it will be 5 into 4 into 3, that is 5 into 4 is 20, and 20 into 3 is 60. So in 60 ways we can fill up the digits x1, x2, x3. So that means how many digits are there? There are 60 digits. 60 digits in second part. So this is how we have got the answer of. So here we can say that therefore number of digits when the repetition of digits is not allowed is equal to, therefore number of 3 digits, therefore number of 3 digit numbers when repetition of digit is not allowed, when repetition of digits is not allowed, and that is equal to how many ways? 60 ways. So that means there will be 60 different numbers. So 60 numbers. So this is the answer of question number 1, both parts 1 and 2. Exercise 7.1, question number 2. How many 3-digit even numbers can be found from the digits 1, 2, 3, 4, 5, 6? If the digits can be repeated. So solving question number 2, let the 3-digit even number be. Let the 3-digit even numbers be of the form x1, x2, x3. Now here what is given us, that is the digits 1, 2, 3, 4, 5, 6 can be repeated. Here the digits 1, 2, 3, 4, 5, 6 can be repeated. So they can be repeated, and moreover what is required is that the number should be, the 3-digit number should be an even number, and when it is even, if the last digit of any number is a multiple of 2, that is it should be either 0 or 2 or 4 or 6 or 8. So first of all, to make x1, x2, x3 as even number, what we'll do, we'll fill up x3. x3 can be filled up, x3 can be filled up in how many ways? 2, 4 and 6, because it has to be even. X3 can be filled up in 3 different ways. In 3 different ways. That is by 2, 4 or 6. Now next we'll fill up x2. So x2 can be filled up in how many ways? How many digits are there? There are 6 digits. So x2 can be filled up in 6 digits. Any of the 6 digits. So x2 can be filled up in 6 different ways. x2 can be filled up in 6 different ways. 6 different ways. Now similarly, let us here, since repetition is allowed, what it says that how many 3-digit even numbers can be found from the digits 1, 2, 3, 4, 5, 6 if the digits can be repeated. Since the digits can be repeated, therefore x3 can be filled up in how many ways? 6 different ways. x3 can be filled up in 6 different ways. 6 different ways. So therefore by fundamental principle of counting, 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 number of 3-digit numbers which can be found, 3-digit even numbers, by fundamental principle of counting, the 3-digit even numbers, the 3-digit even numbers that can be formed, the 3-digit even numbers that can be formed in total, that can be formed in total are equal to. So what we'll do is we'll multiply in we'll take first in how many ways x3 can be filled up. So x3 here, x3 can be filled up in how many ways? It can be filled up in 3 ways. So we'll write here 3 into, then x2 can be filled up in how many ways? It can be filled up in 6 ways. So here we'll write into 6 into. Now here we have written x3 can be filled up in 6 different ways. So here correction will be there. This will become x1, because x3 we have already taken, so it is x1 actually. So write here x1. So this is x1. x1 can be filled up in how many ways? 6 different ways. So that is 3 into 6 into 6, and that is 6 into 6 is 36. 36 into 3, so 3 into 36, and that is 6 into 3, 18. 18 into so 1 carried over, 9 and 10, so 108. So how many numbers will be getting in total? 108 numbers will be getting. So this is the answer of and this is only when the these are being allowed to repeat. So by fundamental principle of counting, the 3 even numbers that can be formed in total, and this is when digits are allowed to be repeated. When digits are allowed to be repeated. When digits are allowed to be repeated. So this is the answer of question number 2 and is complete here. Question number 3. How many 4-letter code can be formed using the first 10 letters of the English alphabet if no letter can be repeated? So solving question number 3, So this 4-letter code, so let the 4-letter code be of the form, let the 4-letter code be of the form, x1, x2, x3, x4. And what we have to do in this one is we have to use the first 10 letters, and letter cannot be repeated. Since we have to use the first 10 letters, the first 10 letters, the first 10 letters of the English alphabet, of the English alphabet, and no letter is being repeated, and also no letter repeats, no letter repeats. Therefore, we can say that x1 can be filled up in how many ways? X1 can be filled up in 10 different ways. So x1 will be filled up in 10 different ways. X1 can be filled up in 10 different ways. So this x1 we have filled up, that is in 10 different ways. Now out of 10 letters, 1 has been used here, so remaining for x2 will be 9. So x2 can be filled up in 9 different ways. X2 can be filled up in 9 different ways. So x2 can be filled up in 9 different ways. Similarly, we can see for x3 also. This is our x3, x2 is over. Now x3, one digit has been used here, one has been used here. So out of 10, 2 has been used. One for x1, one for x2. So for x3 we will have 10 minus 2, that is 8 8 letters will be used. 8, here we have not used digits but letters. 8 letters can be used for x3. So x2 can be filled up in 9 different ways. x3 can be filled up in how many ways? 8 different ways. 8 different ways. Now same way x4, because one letter has been used here, and so one has been here used for x2, one for x3. So out of 10 letters we have used 3 letters, so remaining will be 10 minus 3, that is 7. So x4 can be filled up, and here we have to remember that repetition is not allowed here, since we have to use the first 10 letters of the English alphabet, and also no letter repeats. Repetition is not allowed. So therefore x4 can be filled up in how many ways? 1 less than 8, because already 1 has been used for x1, 1 for x2, 1 for x3. So out of 10, 3 has been used. So 10 minus 3 is 7. So x4 can be filled up in 7 different ways. 7 different ways. Therefore, we can say that the number of ways in which 4-letter code can be formed, therefore number of ways in which 4-letter code, number of ways in which 4-letter code can be formed. When no letter being repeated, when no letters are repeated, under given condition, is equal to how much? So we'll be using here fundamental principle of counting. What it says that we have to simply multiply, because Filling up x1, x2, x3, x4 is a continuous process. So x1 can be filled up in how many ways? 10 ways. x2 in 9 ways. x3 in 8 ways and x4 in 7 ways. So multiplying them, we'll have 8 into 9 is 72. 72 into 7, that is 72, 14, 1 carried over. 7 into 7, 49 plus 1, 50. So this will be 5040. So how many ways are there? There are 5040 ways. So this is the answer of question number 3. Question number 4. How many 5-digit telephone numbers can be constructed using the digits 0 to 9 if each number starts with 67 and no digit appears more than once? So solving question number 4, solution of fourth one. Let the 5-digit telephone number be of the form. Let the 5-digit telephone number be of the form x1, x2, x3, x4, x5. Now what it says that the first two digits of the telephone number should be 6 and 7, since uh, here x1 will be filled up by the digit 6, will be filled up by the digit 6. It's not 6 times, only digit 6 will be filled up by the digit 6, and x2 will be filled up by the digit 7, will be filled up by digit 7, Therefore remaining digits will be, how many remaining digits will be there? Therefore remaining digits are 0, 1, 2, 3, 4, 5, then 6 and 7 has been used, so 8 and 9. So how many there are in total? This is 10 minus 2, that is 8. So there are 8 digits which can be used up. Now x1, x2 are already filled up. There, so to get the 5-digit telephone number, we'll have to start filling with x3. So here we can say that x1 is filled up in one way. X1 is filled up, therefore x1 is filled up in one way. Filled up in only one way. Then x2 is also filled up by the digit 7, that is only one way. x2 is filled up in one way. x2 is filled up in only one way. And what about x3? Here we are having x3. x3 we can, because repetition is not allowed, so remaining we are having 8 digits. Out of 8 we can fill up any, in place of x3 we can put any. So x3 can be filled up in 8 different ways. x3 can be filled up in 8 different ways. x3 can be filled up in 8 different ways. And same way, if we move further, we will go for x4. Now x4 can, because already we have here 8 digits, out of that 1 has been used here. Out of this 8 digits 1 has been used, so x4 can, and repetition is not allowed. x4 can be filled up in how many ways? 7 different ways. In 7 different ways. And the last digit, that is x5. x5 can be filled up in how many ways? 1 less than 7, that is in 6 different ways. So x5 can be filled up in how many ways? 7 minus 1, that is 6 different ways. Why 6 different ways? Because repetition is not allowed. Filled up in 6 different ways. What is the reason? Reason is that repetition is not allowed. Repetition is not allowed. Therefore, we can say that the in x3 the number of ways in which can be filled up is 8, x4 is 7, and x5 is 6. 1 being reduced. Reason is that repetition is not allowed. Not allowed. So therefore, now we'll find out in how many ways we can fill up the we can get the 5-digit telephone number. Therefore, number of ways in which 5-digit telephone number 5-digit telephone number can be obtained in this case can be obtained is that is equal to here x1 can be filled up here. Let us go back in the 5-digit number, that is x1, x2, x3, x4, x5. x1 can be filled up in how many ways? This is one way. x2 in one way. x3 in how many ways? 8 ways. And this is 7 ways, and this is 6 ways. So we just by fundamental principle accounting just multiply them. So what we'll be getting is number of ways in which 5-digit telephone number can be obtained is equal to 1 into 1 into this is x3, that is 8, x4, that is 7, and x5, that is 6. So this is equal to 8 into 7 is 56, and 56 into 6, this will give us 6 into 6, 36. 3 carried over, 6 into 5, 30, and that is 336. So 336 ways we can fill up, or we can get the 5-digit telephone number. So this is the answer of question number 4th one. Question number 6th one. Given 5 flags of different colors, how many different signals can be generated if each signal requires the use of 2 flags, one below the other? So solving question number 6th one, solution 6. Here to generate the signal we require 2 flags. So let the signal be of the form x1 x2. So we have to fill both x1 and x2. Now we are having 5 different we have 5 flags of different colors. So that means x1 can be filled up in how many ways? 5 different ways. x1 can be filled up in 5 different ways. X1 can be filled up in 5 different ways. So out of 5 flags we have used 1 flag here, and what it says that since 1 flag has been used here and the signal should consist of 2 flags, so we'll use one more flag at x2. But for x2 how many flags we can use now? Out of 4 flags, because 1 flag has been used for x1, so only 4 flags are remaining now. Out of 4 flags we can use any one. So x2 can be filled up in how many ways? 4 different ways. So we can say that x2 can be filled up in 4 different ways. 4 different ways, as 1 flag has been used for x1, as 1 flag has been used for x1. So therefore what we can say that then so this is 4. So therefore number of ways in which the signals can be made, the number of ways in which the different signals can be made. Therefore number of ways in which the different signals can be made, signals can be made is equal to, what we'll do now is we'll use the fundamental principle of counting. See here, we have to fill up x1 and x2. So x1 we have filled up by 5 ways and x2 by 4 ways. Just simply we'll multiply them. So that is how we'll do it here. Can be filled up number of ways in which the different signals can be made is equal to 5 for x1 and 4 for x2. That is, there are 20 different signals which can be made. So with this, this question number 6 is complete, and also exercise 7.1 is over.